Hello everyone, welcome to week 6 video solving multi-step equations for my Algebra 1A class. Let's get going. So, solving equations. We've been working on that the last couple weeks, or last week here. As you're doing week 6, watch this video. Use our textbook resources. There's lots of videos I have online. There's examples that you can read through, problems you can work on. And make sure you do the weekly assignments. Come online to my classroom if you need help on anything. Here's what we're going to be learning for week 6. How to solve multi-step equations by simplifying the expression on each side first. We're going to use the distributive property and combine like terms to help simplify and solve multi-step equations. And then we're going to solve equations that have variables on both sides of the equal sign by adding or subtracting a variable expression from both sides. Once we get all that, we'll actually apply algebra equations to represent and solve some problems. And then we'll start touching a little bit on ratios and proportions as a way to represent real-world situations. So a lot of stuff here. Week 6 is a tough week because we get into some pretty complex equations to solve. They take several steps. Hopefully you finished week 5 and feel pretty confident on that. So we can definitely build on all that. So quick review, two-step equations. Remember, solving equations, we know what the expression should equal. I know 3 times some number minus 9 equals 26, but I want to work my way backwards to figure out, well, what is that starting number? So to do that, we use these algebraic ideas. An equal sign, I can do things to both sides, and we do the opposite order of operations. At this point with a two-step, we get rid of whatever is being added or subtracted first. Right now I have 3x minus 9, and I don't want that there. I just want 3x. I want to simplify it down. So I'm going to add 9, because that's the opposite of subtracting 9. 3x minus 9, but then if I add 9 to both sides, that all goes to 0. And all I'm left with on that side of the equation is just 3 times x. And it equals 26 plus 9, because I have to add 9 to the right side as well. So that equals 35. Okay, now I have 3 times some number x equals 35, but I don't want to know what 3 times x is. I just want to know what x is. I want to try and isolate that variable. I want x all by itself. So the opposite of multiplying by 3 is to then divide by 3. I'm going to divide both sides by 3. 3 divided by 3, that cancels each other out. X times 3 divided by 3 leaves just x. That's what I want. Nice. We've isolated the variable. But now we got to do 35 divided by 3 as well. 3 goes into 35 11 times with a remainder of 2. 2/3. So good, there's my solution. If x is 11 and 2/3 and I multiply it by 3 and subtract 9, it will equal 26. That's a two-step equation. Deal with whatever's being added or subtracted first and do the opposite, and then deal with multiplication and division second. What we'll see is as we get into more and more complicated problems, we'll simplify things. We'll rearrange things, but eventually we'll turn every equation into a two-step equation. And so if we're already comfortable with this, then we've already got half the battle done on solving equations. All right, so as we tackle more complicated equations, we're going to be dealing with combining like terms. What that means is we can add or subtract terms that have the exact same variables. 3x plus 8x. I can add those together to make 11x. However, if I have negative 2 plus 3b, I cannot add those together. Those are not like terms. I can't combine them. So they have to have the exact same variables to the same power variable, then I can add them together, combine like terms. We're also going to deal with the distributive property. Remember, we did that a little bit earlier, but if we have 3 times 2x plus 4, I can distribute the 3 and rewrite that as 6 times x plus 12. That's the distributive property. I want to take away parentheses to open things up to make it easier for me to move things around in my equation. So if I have parentheses in there, I got to use the distributive property to get rid of them. That's usually one of the very first things you do when you're solving equations. If you see parentheses grouping things up together, distribute so we can remove them, and then we can do all these other stuff like combining like terms. All right, let's do that. Let's use the distributive property and combining like terms and work backwards to solve this equation. All right, I'm going to draw my line down my equal sign because that helps me keep both my sides and do the same thing to both sides. But before I start adding or subtracting or doing things to both sides, I want to simplify all of this first. Okay, I see some parentheses, so I'm going to simplify with the distributive property. I'm going to multiply this -2 into the x and into the 9. And that's going to give me 5x. -2 times x is going to give me -2x. And then the -2 times 9 is going to give me -18. All right, there's no more parentheses. That's looking a little bit nicer now. Now I still want to combine like terms. I see a 5x and I see a -2x. Those have the same variables. I can combine those together to make 3x minus 18 equals 21. I'm feeling really good now because this is now a two-step equation. We worked on all these last week. I'm pretty good at these. So let's get rid of what's being added or subtracted. I'm going to add 18 to both sides. So that's the opposite of subtract 18. We've got 3x equals 29. And I'm going to divide both sides by 3 because that's the opposite of multiplying by 3. And we see that x equals 3 goes into 29, 9 full times get 27, and there's 2 left over. So 9 2/3. That is my solution. And again, what did we do? We first distributed, collected like terms, and then once we did that, we had a two-step equation that we then solved out. Okay, we're also going to be having cases where we need to solve equations with variables on both sides. That's not helpful. To be able to solve it, I need one variable on one side of the equation. So if you see here, we're going to be doing some adding or subtracting not only to numbers, but to variables as well to get rid of them on one side or the other. Let's show you what I mean by that. So here we go. 9 times x minus 2 equals some number 3x plus 3. And we can see we got a variable on both sides. All right, let's draw my line down. Hopefully you already saw the parentheses there, and let's do it. Let's distribute the 9. So now I've got 9 times x minus 18 equals 3x plus 3. All right, I've got 9x on the left side, I got 3x on the right side. In this case, I need to get rid of the x's variables on one side or the other. So this 9x is positive, so I could subtract 9x from the left side and the right side, and that would get rid of all the x's there. But I have a positive 3x on the right side, so I could also subtract 3x from both sides and get rid of the x's on the right side. I'm going to subtract 3x because that way I'll leave a positive term for x on the left side of the equation. I'm feeling better about positive numbers than I am about negative numbers. Now what happens? 3x plus 3 minus 3x, what happens to my x terms? Boom, they're gone. They go to 0, and all I have left on the right side is 3. Now on this left side I have a 9x minus 18 minus 3x. These are like terms, and 9 minus 3 gives me 6x minus 18. Now I have one x variable on one side of the equation, and I can now solve it. In fact, this right here is a two-step equation. This is just what we were doing all last week. So let's add 18 to both sides. Minus 18 plus 18 goes to 0. 6x equals 21. Divide both sides by 6, and x equals 6 goes into 21 3 times. 6 times 3 is 18, but then there's 3 left over. And I can rewrite that as 3 1/2. Okay, there's an example of having to add or subtract a variable expression to both sides to make sure there's only one variable on one side of the equation. Finally, when we have equations with a lot of fractions, one good strategy is to multiply both sides of the equation by the least common multiple of the denominators. That way all the fractions divide out and leaving only whole numbers. So take this example. This looks really messy. I know a lot of you have a phobia when it comes to fractions, right? Gosh, how do I solve this thing out? It's too hard. Well, we can use our ability to do algebra to multiply both sides of the equation in such a way that it makes it a lot easier to work with. On the left side, we have a 1/4, right? It'd be nice if I didn't have that, but on the right side I have a 1/5. When I look at that, I want to multiply both sides of the equation by a number that both divides by 4 and divides by 5. The easiest one is 20. So watch what happens when I do this. I'm going to take all of the left side, use my parentheses, and I'm going to multiply it by 20. And I already got parentheses on the right side, so I'm going to multiply all that by 20. And watch what happens. So we have 20 times 1/4. 20 times 1 gives me 20, divided by 4 gives me 5. That becomes just 5x. Now I have to use the distributive property, so the 20 also multiplies the 3 to get 60. So make sure you don't forget that. That's going to be what some of you mess up on. You're going to multiply the fraction and you're going to forget to multiply all the other stuff. Now on the right side we've got 20, but also multiplying by 1/5. 20 times 1 is 20 divided by 5 gives me 4 times 2x plus 11. So it doesn't matter when you're multiplying, it doesn't matter the orders. We did 20 times 1/5 first to get 4, and then I can multiply it by the parentheses. I'm going to go ahead and use the distributive property here to get 8x plus 44. But now look at this. We just did some multiplication by 20, which wasn't so bad. But my equation now, there's no more fractions. I like that. It's easier to work with. I got variables on both sides. I got 5x and 8x. I only want variables on one side, so I'm going to subtract 5x from both sides. That makes the x's on the left go to 0. So now I've got 60 equals 3 times x plus 44. Now I've got a two-step equation. I love two-step equations. I'm going to subtract 44 from both sides. And we've got 16 equals 3x. Divide both sides by 3. And x equals 5 1/3. So I can get a fraction answer, and that's okay, but notice I didn't have to do any fraction stuff all the way throughout because I multiplied both sides of the equation by 20 just to get rid of fractions off the bat. All right, so this week, make sure you practice this. There's some good examples. I have some good examples on the paper pencil problems. Simplify both sides of the equation first. Use the distributive property. Add together like terms. Make sure you have one variable on one side of the equation. Subtract them off if you need to. And then work backwards and solve the problem using what we did with our two-step equations. Always check your solution as well. You can use your Desmos calculator. You can plug it in. Make sure you're on the right track. There you go. That's solving algebraic equations. Let's do a word problem. Let's kind of play around with translating again a problem into the right equation that we can then solve. A factory manager is packing engine components into wooden crates to be shipped on a small truck. The truck is designed to hold 16 crates and will safely carry a 1,200-pound cargo. Each crate weighs 12 pounds empty. Here's the question. How much weight should the manager instruct the workers to put in each crate in order to get the shipment weight as close as possible to 1,200 pounds? All right, there's a lot of information here, right? So let's think about what we got. So x is my variable, into my unknown, and I want x to be the weight in each crate. Now let's start putting things together here. I know that a total, this 1,200 pounds, is the most weight that I want. So stuff has to add up to get to 1,200 pounds. Now what's going to add up to 1,200 pounds? 16 crates, right? So I'm going to have 16 crates. And in each of those 16 crates, they already weigh 12 pounds. But there's also the weight that we need to add. And I want to know each crate is going to be 12 pounds plus whatever I add to it. There's 16 of them, and all 16 crates have to be a total of 1,200 pounds. Can't be more than that. There's my equation. 1,200 is the total pounds. 16 is the crates. Each crate holds 12 pounds of its own weight plus whatever each worker adds to it. All right, let's solve this out to find out how much pounds should be in each crate. I'm going to divide both sides by 16 because that's the opposite of multiply by 16. 16 divided by 16 leaves x plus 12 equals, I gotta knock my calculator out here. 1,200 divided by 16 equals 75. So each crate has to be 75 pounds, but I have to subtract the fact that the crate itself weighs 12 pounds. So what do we get? I can add 75 minus 12, 63 pounds. So each worker adds 63 pounds of cargo to each crate. Remember to fully answer the word problem. There we go. It's a good one, huh? All right, let's do a little bit of ratios. Ratios is a good middle school topic. Hopefully you guys remember some of this stuff. Ratio is simply a comparison of two numbers, measurements or quantities. We work with the ratios all the time in the world. Whether we're driving in your miles per gallon, for your health, heartbeats per minute, what's your heart rate? Science, we got meters per second squared is our acceleration. In business, we want to know the profit per quarter. Are we increasing or decreasing? Shopping, we can buy 5 cans for $3. And in construction, what's the price per square foot of that house? These are all ratios. We can write them as per like this, or we can write them as a fraction. Or we can write them with a little colon, miles to the gallon. Let's do some stuff with ratios. What is the ratio of students to teachers at a school if there are 235 students and 17 teachers? Well, the ratio is students to teachers. So I need to set it up as 235 to 17. 235 students to 17 teachers. I could also rewrite it as a fraction. 235 students to 17 teachers. Now, if I really wanted to have fun, I could then turn that into a rate by dividing them. If I take 235 divided by 17, I can turn my ratio into a rate. There are 13.8. I'm going to round it to 1. That's 235 divided by 17. So there is 13.8 students per teacher, per one teacher. So there's a ratio right here. Oh, I did ration. I don't know why I did that. Ratio. It's right there. And then this is my rate. All right. That's it. That's our week 6. So we'll do more on rates and ratios next week. I just wanted to start getting your brain juices thinking about that. But week 6, make sure you are putting the heavy work into being able to solve multi-step equations. The rest of your math career will be much easier if you can get this stuff figured out and get comfortable with solving equations. But this is what we did. Solve them, use the distributive property, combine like terms, simplify, get to where you're solving a two-step equation, and then solve problems. Let me know if you have any questions, and I hope this is helpful for you this week.